Okay, so I'm assuming that everyone here is hoping to walk away with some additional ways to be able to see the fun in math versus the tediousness that math can present sometimes. And so our contact information is there. I'm Christine Chugg. I get to teach the high school students, and with me is Miss Flynn.
I get to teach the 5th grade through the 8th grade, whom I love and adore. Every one of them. Wonderful.
And we wanted to just make sure that people understand or saw it in a different way, that so often reading and writing is considered like, oh, that's an all-encompassing, it needs to be taught to everyone. But math is also considered to be a universal language, because in every single language that's spoken, there's still that concept of multiplication, division, derivatives, integrals. It all comes together. And when you even study the history of math, all the pieces that came together from different parts of the world to even get to where we are, it's really awesome. And my students always find, oops, I did not mean to do that. My students always find it baffling when I first introduce my classes to say, if you really think about the math that you're learning, it's one giant puzzle. It's looking for patterns. Now, yes, the patterns you're looking for overall in kinder and first and second is very different than the patterns you're looking at when you get into high school math and all, but it's still looking for patterns and seeing how pieces interact with each other. What we're going to present will be just ways to try to reinforce what your children have already learned or will be learning in their math journey. And this is just a range of ideas. By no means is this all encompassing. We're just hoping it gets you thinking of new ways to look at things and interact with different parts of your everyday life. And if you guys have ideas that you've incorporated into how you teach your children math and all, and it's not covered here, but it's been like almost like an aha moment for you, by all means, we'd love to hear about it. We love hearing new ideas because it encourages us, and then we can encourage others, and it just keeps growing. And then in terms of our math classes, this is not necessarily how parents look at teaching math, but in our classes, because we are doing a wider range of students and all, we do have what's called the mathematical practices. And so it's been found that these 8 things that if you work on trying to incorporate, making sure that it's looking beyond like the concrete to looking at the abstract, being able to figure out what tools you have in your toolbox, and in terms of math skills that you can strategically use, looking at precision, when can you estimate, when can you need to be precise, just overall looking at these, it helps build a mathematical mind that allows you to approach the math in any problem that you have in life that has some math embedded into it. So that is a lens that we use as we teach. And now we'll get into more of the fun stuff.
So we're going to be presenting a lot of ideas. So I think one thing you might want to do is just have a pencil handy and just write down 1, 2, 3, 4, 5 things that you think maybe will be useful for you as we go through all the different ideas that we have for you. Reading and math connection is definitely there and easy to develop, especially starting when our kids are young, reading to them. 1 fish, 2 fish, red fish, blue fish. There's so many different counting books, the Hungry Caterpillar, the I Spy books, finding things, looking for patterns, getting number sense, learning about sequencing. It's a good way to start just their math sense as they get older and have to do more difficult things. Siblings can read to each other. As your kids get older, when you are reading things to them, maybe ask questions for comprehension, not necessarily math questions, but like what word in the sentence tells you how Harry Potter felt when such and such happened, or why do you think this happened? What do you think might happen next? That ability to find specific details and pull things out is going to be really helpful when the kids start having story problems and have to look at the problem. Do I need to add? Do I need to subtract? I need to pull out important information. So that kind of having those conversations and pulling out information as the kids get older, last year, one of my favorite things, there weren't a lot of favorite things about Zooming, but one of my favorite things is when the fifth graders would share Lego things that they've made. And so following directions, building the Starship Enterprise, sequencing, counting how many Lego pieces you need to make the different parts. All of this is just part of important things and important steps, developing skills that they can definitely use in their math classes.
Yeah, I did want to make sure that people know that if they'd like to have this slide presentation, we can share it. So if you want these details and you feel like you have to write it all down, we will make it available to those of you who'd like it. And then I wanted to highlight, because a lot of the books that we just listed here are picture books. And so it looks like it's very limited to just like elementary side of math, but in particular, the circumference series I've used with my geometry classes in high school. This was before we went to the integrated model. And the kids loved it. It helped them be able to see the connections between the different terms that we use, because that's a big part of math, is being able to know the vocabulary. I've had the privilege of actually seeing Greg Tang do a presentation about his books, and oh my goodness, you want to see someone who's passionate about math and how it integrates. He is an awesome one, and we actually have his website on our last slide as a resource if you guys ever want to look at it. I've used some of his books, and then the greedy triangle I've actually used in a trigonometry class because it talks about, you can integrate it into limits. So even though they're picture books, they're not limited to just elementary level. And this is a very, very limited list. These were just some ones that we wanted to highlight for you guys. I actually have shelves and shelves of math in my personal library at home of just different things that I work with and use with my munchkins, as well as being able to keep my mind sharp. So there's lots to them.
Okay, game time meets math time. We have our headbands on because game time meets math time is fun. And we have a list of games here, and I'll just go over a few of them, some of the favorites that I've noticed in my class. But when we are done with class early or at tutoring time, if the kids are done with their homework and done with their corrections, then we have a bunch of games that I pull out. And my favorite thing is just walking around, listening to them, having those conversations, having those like, well, if I do this and you do this, then figure out strategies. Why playing games at home is good for math is because it's developing logic skills, you're increasing your problem solving skills, you're increasing your number sense, strategies, following directions. All of these are important things that they're going to need as they attack their math problems. Bouncing ideas off of each other, looking for patterns, practicing persistence and not giving up. If this doesn't work, well, how am I going to win this Connect 4 game? Or how am I going to win this checkers game? I need to try a different strategy. They're all math skills, and then there are life skills too, just as the kids go through different parts of their life that isn't math. But they're having fun and they're practicing math skills. So for example, Connect 4 strategy game. So I would just looking at patterns. For the little guys, hi-ho, cheerio, shoots and ladders, of course, are good for like counting skills. Let's see, the Rubik's race, there's a picture of that to the left there in the middle of the screen. That is the all-time favorite. I have 4 different games of that, and so 8 kids can play. And it's a strategy game looking for patterns. It is so fun. It's really fast-paced, and everyone plays at the same time. Great game for your family. The Uzzle game, which is to the right there with those like kind of blocks. You flip over a card, and then you have to arrange the blocks in the pattern. So it's looking for patterns, trying different strategies to get it to work. Jigsaw puzzles. We have a bunch of jigsaw puzzles in the classroom. Some of them are really big, like 4 feet wide. And so looking for patterns. How do we put this together? Oh, try and do it upside down. If you can do it right side up, let's try it again and time yourself and see if you can do it faster. All of these are just different ways to practice skills and develop skills. So when it comes time to do the actual math homework, they've got some skills developed, and it's fun. It's family fun. They can play with their friends. It's fun.
And then I was also going to say, like with stuff like Battleship and Connect Four, you can also look at, do you have a greater chance of winning if Connect Four, you don't allow the diagonals to happen? In Battleship, if we did allow a chance to be able to place those ships at different angles other than horizontal and vertical, does it change your chances of being able to sink that other person's battleships? Does it make it more difficult? Looking at those things, but then it also gives a context to start teaching kids. They already have a visual in their mind in terms of when we start looking at coordinate grids for graphing and all. Battleship and Connect Four has already laid that visual foundation for them.
Duco, you like that one?
Okay, stirring with math in the kitchen. Kids love to cook, love to bake, and experiment in the kitchen. So you just need to allow yourself a little extra time when you have them helping in the kitchen, because sometimes it takes a little longer for cleanup. But following a recipe is excellent for reading skills, following directions, doing things in a certain order. One of the things in math that's important, and when you do a problem, is order of operations. You have to do multiplying and dividing before adding and subtracting. So the same thing in a recipe, you have to do things in a certain order to have your delicious product at the end. Fractions, using teaspoons, quarter teaspoons, half teaspoons, great practice, just so kids get a sense that a fraction is part of a whole. Because when we get to fractions, that's an area that gives people a lot of trouble. So cooking and baking is a great way to practice that. We need 2 cups instead of 1 cup. If we're doubling a recipe, what does doubling mean? We have to double all the ingredients. If we're having a recipe, we have to cut everything in half. So it's taking half of a fraction or half of a whole number. Great practice. Okay, that's it for that. If you want to talk about the other part.
Okay, and then one of the ones that might seem a little funny is like different ways of cutting up fruit. Like my son, he is so happy that he gets to use something other than a butter knife to be able to help me in the kitchen. And so he, when he gets to cut up like cantaloupe and that sort of thing, he's always trying to see what new geometric shapes he can make with the fruit. Like she said, it makes it take it longer, but at the same time, we're having a discussion and he's having fun. And then we know so many things have turned to digital, but if you have tucked away in your utensil drawers or that sort of thing, any of these analog thermometers and scales and that sort of thing, they are so important in terms of being able to read, like with the thermometer there in the middle, it's like a candy thermometer, deep fryer thermometer. To be able to read vertically versus horizontally, that's one of the most disadvantage that it makes for kids if they think everything has to be horizontal, because that's how we present every single number line all along. And then all of a sudden we throw it at them when they start graphing that it's vertical as well. Being able to read in between, so many kids don't learn how to read a clock. And so even if your whole house is turned to digital clocks, learning how to read these thermometers and scales can help them to read the pieces that aren't labeled, because we can't write that microscopic on everything. How are we doing? You guys feeling like you're throwing too much at you already? We're good, yay.
When I ask the kids in class, like, when do you use math most in your everyday life? They almost invariably say with money. So some ideas as far as practicing with money and getting some number sense with that. Comparing prices at the store is a great thing to do. We're going to be starting on unit rates in 6th and 7th grade. Here's a big bottle of Gatorade that costs $5, and here's 3 smaller bottles that cost $1.39. Which is cheaper per ounce? In the bins at like where you buy sunflower seeds and stuff at Sprouts yesterday, I was there getting something, and the lady next to me was there with her son, who was about 9. And I was thinking about this talk as I was listening to them, because she was putting stuff in the bag and she had him write down the bin number on the little tag. And so he wrote down the wrong bin number. And so she was showing him how what she was buying was like $3.49 a pound, but the bin number he wrote down was something, it was like fancy chocolate pretzels that were like $15.49 a pound or something. And so they had this big discussion about like, how much is it per pound? This is way too much. We would never pay this much for chocolate pretzels. And so it's just number sense, getting him familiar with numbers and how to use numbers. If your kids get money like from grandma or grandpa or whatever, saving till, you know, work with them like you can save half of it and you can spend half of it, or open a checking account. Just getting them an idea of money sense and how that applies to them. I'm gonna, let's see, yeah, go ahead and then I'll go into the lesson.
So, and then just getting them used to, like I said, vocabulary is a big thing, and not just necessarily in the math vocabulary, but just the vocabulary of everyday things. So like when they first get a chance to be able to open a savings account, talking to them about what it means that they're earning interest. Yes, their savings account will probably be earning just pennies, so they won't think that that's necessarily significant. But what does it mean, and how does it look different with your savings account that has a little bit more, hopefully, than theirs does? And what that interest actually means. Because like in high school, I get to them and talking to them about, you know, simple interest versus compounded interest, which yes, compounded interest, which is what the banks do, is a very complicated formula. But just knowing that when you use the simple interest equation, it approximates it so they can have an idea of how much they'll earn in savings for that year or that sort of thing. With little kids, as they do start to get money, whether it be allowance or some, you know, working chores of like they get to go mow neighbors' yards, or they got old enough to start doing some, you know, niece is getting dropped off and you're going to get paid $1 an hour to help watch them, or that sort of thing. Having a notebook where they keep track of how much they earned and how much they spent. And then as they get older and more sophisticated, switching it over digitally and being able to show them that if they use like Google Sheets or Excel or whatever platform you prefer for a spreadsheet, they can actually use formulas and make the computer do their calculations for them. So something that starts when they're younger can then get more sophisticated as they've learned more things. My kids love to be the banker in games like Monopoly and all, because not only do they get to control the mass majority of the money, but it also gives them a chance to be able to know how to count back money, because you know, you only have that $10,000 bill, but you only had to pay them $3 or that sort of thing. And then we always run out of those $100 Monopoly monies. And so then they have to figure out how to exchange it so no one got cheated. So it's like time out in the game. Let's get it so we have money because the banker ran out of $100s. But then that also sets them up for being able to count back change. In my college days, before I became a teacher, I managed a concession stand. So I got to supervise quite a few high schoolers. And one of the most eye-opening things to me was how many of those high school students could not count back change. So if the people were supposed to get, say, 27 cents back, if there was not a quarter in the drawer, they weren't always able to figure out how to be able to count it back. Because I was like, well, how else can you make a quarter? And they're like, oh, okay. But like just that problem solving, that the change didn't always have to be a quarter and 2 pennies. There's a reason actually why McDonald's spent so much money to have their coin machines where it just dispenses it down. They were losing thousands of dollars on a regular basis because their employees couldn't count back change. So just being able to have that skill gives them an upper edge to being able to hopefully one day find gainful employment. And then the coin riddles is actually something my own munchkins came up with. My son is the best at finding coins. I swear, he can be in a store for about 2 seconds and already found like 3 coins. And so they started doing, hey, I have 7 coins. It's a total of 72 cents. How many of each type of coin do I have? And so that helps my daughter with her number sense in terms of a quarter's worth this much, a dime's worth this much, that sort of thing. But it's also laying the foundation for how to solve systems of equations, which if any of you guys have kids in high school or you remember your high school days, those are some of the more complicated things because you're having to keep track of a minimum of 2 variables going on. So the more you have a sense of how things are interacting with each other, such as the coins and the total, the easier it makes to be able to look at problems like that and go, I can work with two different things going on. And then again, businesses like it because you can hold on to, you know, your profits and your costs and all that sort of thing.
One thing that we did when my kids were little, like they love to go to the Goodwill store and get stuff. And so there's so many things you can do with that, just with budgeting money and number sense. Like you could give them each $10 and say, okay, you've got to buy a gift for everyone in the family. And so they have to estimate how much each thing costs as they're walking around looking for things. Another idea they had one time that they went with a friend and they had $10 and they had to buy an outfit for the other person and then they had to wear it. So like a shirt, shoes, and pants for $10. So once again, rounding numbers, estimating. For the little guys, you could pay the tax if you want, since they aren't so familiar with what tax is. And then for the older kids, who will know how to do percents, they could just take 10% of their estimated total to make sure they have enough tax. So once again, it's building those skills of number sense for what they have to do for their specific project. One thing I've noticed, which I'm trying to have more conversations with students in class as they get answers. So for example, a lot of times when we're doing percent problems, it's like leaving a tip in a restaurant. So the problem could be something like, we are spending $20 for our dinner. We want to leave a 15% tip for the waitress. How much money does a waitress get? So correct, I'm correcting papers and someone has the answer of $30. And so then that's such a great opportunity to start a conversation like, well, you know, 15% tip is less than the total of $20 and you're so nice, you're giving this waitress a $30 tip. What is wrong here? Oh my gosh, the decimal point's in the wrong place. So just those kinds of things. And it reminds me of when my daughter got her first job. She was working for Barnes and Noble. And so she knew how many hours she worked. She knew what her pay per hour was. She was getting ready to get her first paycheck, had it all multiplied out, kind of planning what she was going to do with her money. And then of course she gets her paycheck and it's less. And she's like, what is this whole tax thing? Okay, that was a whole nother conversation. So then the next time she would estimate how much the tax was going to be, deduct that. So she'd know how much money she'd have to work with. So number sense, number sense, number sense.
All right. And then, so another place that can be fun is looking at math and art. So tangrams is a really fun way just to get kids. You can talk about the shapes and all. And an example of a tangram is up there in the upper right-hand corner with all the colorful triangles and rectangles and everything like that. And so that was just a really fun one. And most kids get used to it where if they do work with a tangram, they're taking it and they're trying to make a bunny out of it or a duck or a boat or that sort of thing. And that's really great because they're getting the chance to be able to look at how do these shapes interact? How can I fill the space that they're asking me to fill with the limited shapes that I have? But it does extend beyond that. I did an entire geometry final where it was completely a tangram. So they spent 2 days, about 4 hours working on a tangram. And the first thing they had to do was construct it. So they had to practice their construction skills. And then once they did that, they had to calculate the area of it and the perimeter of it. And then they had to create all the different shapes of a triangle, a quadrilateral, a pentagon, a hexagon, an octagon, all the different ones, and then see what's happening in terms of how did the area change, which it was fascinating to watch them finally have that aha moment of it never changed. But then some of them tried to draw the conclusion, well, if the area didn't change, then the perimeter didn't. But then the discussion, because they were doing it in groups, but it did. And so then that really made it come to home, the fact that area and perimeter, they do have relationships, but they're not directly tied to each other that tightly. Tessellations and symmetry, that is really great for watching for patterns that are visual. And we have a fringe pattern of a tessellation there at the bottom there that kind of looks like wallpaper-ish. Kids love to be able to just play with geometric shapes similar to the tangram, but then there's more that you can work with, and you can just have them make a collage and try to make a picture. And if you kind of look behind us, we are in front of the second grade board, and they've been learning about different artists, but they also were kind of doing geometric shapes because they were trying to approximate that. I don't know if that was really a focus of their lesson, but I look at it that way, going, that is a really awesome, great use of geometric shapes to make some designs. Building with geometric solids, that just helps them to be able to understand what 3D shapes are. Because when you get to high school, everything's just drawn on paper. And so it's very hard to visualize some of them, like especially a sphere. And so the more that they interact with those solids, the better. If they love drawing, learning how to draw them, because if you can draw them, then you can also read pictures when they're given to you. Because yes, we're trying to say that we don't always practice on pencil and paper, but at the same time, that is still a reality for quite a bit of it, because we do still have to turn in work samples and all. The golden ratio, I'm always fascinated to learn more depths of it. And we get to see the Mona Lisa down there. And not sure if it was painted with the golden ratio in mind, but they found that the golden ratio, which is created by that spiral that's driven by the Fibonacci sequence, is considered to be, when you put a rectangle around it, one of the most pleasing ratios for us as humans to see. It's a very pleasing thing to the eye and the brain. Yeah. Sorry, a lot that we're trying to get out to you guys, and we will have a Q&A. Okay, so we talked about symmetry a little bit, but I want to make sure that like out in nature is also a great way to look for it. And I mentioned with Fibonacci, the sequence that kind of creates that spiral that goes with the golden ratio, but it's another one of those that it's like I love to learn more and more about it, because it just happens out in nature. And it's a sequence where you start with 1, 1, and then you take what's considered 2 consecutive numbers and add them up, and that gives you your next number, and so on. And so the numbers of like 3, 5, 8, it happens with the number of petals. Then you can watch the spiral on a pine cone and that sort of thing. And it just, I love when we really get to see that math is describing the world around us. A rain gauge for little kids, just again, learning how to read stuff that is going in a vertical nature versus a horizontal nature. And then extending it. So if they really loved working with that rain gauge, and every time we had rain, running out there and seeing how much did I collect? How much did I collect? They can also then start to graph some trends and see if they can say, like, you know, when there was a 70% chance of rain, how much rain did we actually collect? And 20%, and see, is there a correlation or not? And sometimes there is a correlation, sometimes there's not, but in just the fact that they're thinking of those questions and trying to see, can I gather the data? Can I analyze it and see if there is something that's actually happening to connect them? I love to challenge my kids and just like ask them, like we go to Target probably way too much. But one time my son was having a fun time of noticing that the basket at the bottom is made of a hexagon. And so I just started talking to him about, well, where else do you see it? And so it's the beehives. And we had learned about these stone structures that form where it's hexagonal in shape and everything like that. And so then we started doing some talking, and we got to discover through just looking at those things that it uses the least amount of material, but yet is the strongest structural shape by using the least material. Triangle is the strongest, but hexagon uses less material than having to have all those triangles. So it's just fun ways to look at it, and then to see that stores will also use those facts to be able to minimize their cost, maximize the having to replace them sort of thing. Concentric circles. That's just circles embedded inside of each other. And if you go to a pond, a lake, that sort of thing, and you skip rocks and just starting to talk to them about that happening, or, you know, you get to see a tree that's been cut down and you can talk about all the rings on it and do the science, but just talking about the fact that this is happening naturally. When they get to high school and I get to talk about concentric circles with them, or you get to do it through an independent program of it, the foundations are already there because they've already been talking about it with a pond. They've already been talking about it with the tree. And then while I started off by saying that math was kind of a way to have a universal way to explain the world around us, it extends to the patterns and shapes in space. And then I'm going to skip over to one little piece about gardening. And there's a picture of a landscape design down there in the lower right-hand corner with the white and black circles and everything like that. A lot of times students love to say, I'll never use this. I'll never use this. You're just teaching me a whole bunch of stuff. Well, when I bought my house, it was just a dirt lot behind my house. And so it became a glorified weed patch after a while. So finally I realized that I wasn't going to get all the sprinklers and everything laid down. So I worked with a company to be able to get it designed, and they love to do things like in that picture where things are swooping and curving and everything like that. But I knew I would have to be mowing the grass, and I didn't want to have to do all those swooping, curving things. So I cut out a cost by being able to design my own backyard, and they just had to talk to me about a few things of like, well, because of sprinklers, let's adjust this or that. And then also when they were quoting me how much cement we would need, they forgot that instead of in terms of square feet for the depth, they kept it as square feet in depth instead of inches going down. And so they were going to charge me like 5 times as much for the cement. And once it's on paper, it's harder to be able to justify you made an error. So luckily, just having a number sense and being able to do conversion, I was able to save myself a lot of money. And I only can imagine how many people paid that higher price because they didn't have that number sense.
I want to talk a little more about gardening. That is a good way to use math, whether your kids are little or older. Looking on the seed packet, how deep do we have to plant these seeds? How far apart should we put the plants? How often do I have to water? How much water? A couple of years ago, before COVID came, we had a daffodil planting project, and that's why the daffodils are down there outside near the tables at lunch. And so we had our math lunch bunch. And that was really fun because the kids had to dig a hole. We had to look on the directions. How deep do we have to plant the daffodil bulb? How far apart can we plant them? So we got all the planting done, and then we had this big chart that we made. So each Friday when we met, we would, each kid would measure like 3 or 4 different daffodils that were sprouting up, and we grid it on a chart. We'd figure out the average height, and then it was fun to see from Friday to Friday how much they grew. So all of these things are fun ways to use math. If you have enough room in your yard, you could give each child like a 3x3 plot, and they could measure stuff out with a tape measure and the ruler, figure out what they want to plant. How wide does a tomato plant get when it grows up? Can I plant them really close together? Do they need a little more room to spread out? If you have a planter box, how much soil do we need to fill up that planter box? So doing a volume calculation. There's just so many ways to use math where it's just fun and integrated into everyday life. When we start our geometry units in junior high, it's always fun, which I love it because there's many manipulatives you can use to like shape triangles or squares or whatever. But the kids are always like, when are we going to use this? And I love to tell the story about some kids in my neighborhood. There's an empty lot and they were building a dirt bike course. And so they would build a jump or they'd have a hump, and then they would have to put a 2x4 on it so that they go up the 2x4 and then end up in the air. So it's really fun to sit there when I was out cycling one day and just watch them with their shovels and boards. Like, oh, this board is too short. We can't get the bike up it. So we have to cut down the hump to make the slope of the board a little bit less, or we have a longer board so we can have a higher jump. It was just fascinating to see them doing geometry and not even realizing they were doing it. But it's those things, those experiences that they're having that help when we start talking about it in class, then it's like something they can apply to real life, to apply to the math situation. Logic puzzles, a lot of math is just like things need to be logical and done in a certain order. So that little logic puzzle there that has a little stack of books, there is a website on the last slide and it says logic puzzles. These are really fun to do, and you could do it as a family or the kids could do it on their own. And this one happens to be a 3x3 grid. So it's like 3 grids across and 3 grids down. But on this website, you can build whatever size you want. You could have it 3 across and 4 down. You can go up to 5x5, 6x6 as they get more complex and you get better at doing it. But once again, it's super fun way to kind of practice some math skills.
And then there's also coding in the lower right-hand corner. That's an example of more of like an elementary, because the kid's supposed to code how the little, I think it's like a little boy there in the picture, needs to travel along the grid to be able to gather everything and make their sandwich. But that lays the foundation to being able to then do stuff like being able to interact with Google Sheets or Excel, that sort of thing, so that they can learn how to give commands and be able to do it. And honestly, even to be able to get my math degree to teach math, I had to do computer programming because it was one of those applications of the math in a more real life situation. Mahjong is one of those of trying to do the strategies in terms of the logic of how I need to remove the tiles to get to the ones that I need that are buried, but I can only kind of see it, so I just can't get to it yet. And the toothpick puzzles, yeah, there's an example where they show the little matchsticks, but of course we want to encourage our kids not to start fires, so I always switch them over to toothpick puzzles. But it gets to be more of a hands-on, get to move things around and be able to logically try to see if you can solve the puzzle. Social media, people love to do it and like, oh, I'm going to pay you $100 if you can get it. And of course, their friend never gets it, so never gets the $100 in those videos. And then our next one, if you're anything like me, you feel like you spend way too much time in the car. And so there's ways to even just have conversations and try to get it so your kids are doing things other than, are we there yet? Are we there yet? Are we there yet? And so, you know, getting them invested into like a trip, you can start talking to them about like, well, how much distance are we going to be traveling? What will our gas usage be with the trip? Cost of admission. Some of them, it'll be cheaper if you go during the week versus a weekend. Hotels, especially with the older kids, starting to get them to understand that even though the hotel is listed as $59 a night, you are not paying anywhere close to that $59 a night, because there's all those extra fees that are involved because of luxury and entertainment that hotels considered and all the different things. But talking to them about that so they're not so shell-shocked when it comes to a problem in class, or whether it's like, or they get out in real life, it's like, hey, I budgeted and I didn't budget right. Doing a cost analysis of would it be better to do a car rental so that we don't put the wear and tear onto our own car. And maybe we can do a car that's more fuel efficient versus the car that we do have, because, you know, dad's staying home with some of the kids because they still have ballet and tap and archery to go to. And so we don't need the big SUV for the trip happening this time. You know, just being able to talk about those things and doing some comparison, or even talking to them about budgeting, how to save for a part of it. Like, you know, this time before we go to the amusement park, how are you going to make sure you save up to be able to buy your souvenirs and your trinkets and all? Because, you know, we're paying for you to get in. You want the extras that's now going to fall on you. How are you going to budget? Because I'm budgeting for the trip. How are you going to budget for your piece? Or, you know, yeah, I know you always love that character shaped ice cream cone, but I just can't figure out how to justify paying for that one anymore. You got to make sure you can do it yourself. To prepare students in terms of, again, those higher level math problems, just talking to them about, like, you know, the speedometer is how I know how like fast I'm going, and all the different things of like how many miles I've traveled, and talking about the pieces of the car. And then getting them to start thinking, well, how do you think the car is able to calculate those things? Because yes, there's an onboard computer to your car, but how is the car, like, what information does the car need for that computer to be able to calculate what I see on my dashboard? I always got tired of hearing from my kids, I'm bored, but then I also don't want to give a book to them to just keep reading, because while we love reading, that also can cause the motion sickness in my family. And so I needed to encourage them to look outside of the window a little more. And so I would have them, I made a little grid with all the different car logos for Honda, Toyota, Chevy, that sort of thing. And so they were able to create bar graphs of just how many they saw. And my son came to me, he's like, do you know that where grandma lives, they have so many more Toyotas than we have in Fresno? And I'm like, wow, like that wasn't even a question I asked. It was just something that he started to do. And so then the next time we traveled to go see grandma in Southern California, I said, well, why don't you see if you still see the same trend, or if maybe they've changed their favorite car. And so it just got him to like do something rather than just complain to me that the car ride was too long getting down to SoCal. And so it was something to entertain him. And then I knew I was laying some foundations of when he did get to more sophisticated statistics, that there was that piece that I could refer back to. And then with my daughter, she got very jealous because her brother got to learn everything ahead of her. And so when he was looking at the car logos and all, I was having her identify shapes. And so it's like, how many circles can you find for me in the next minute? Or, oh, look, there's a yellow sign coming up. Can you tell me what shape that is? And like, while it's a square, it also looks like a diamond, also looks like a rhombus. So then it lays the foundation of where we can start expanding it, of these things that you're learning, the words that she did know, we could then move on to different higher things as she got older.
Math facts can be fun. One of the foundations for like doing math problems, especially as you get into the older grades and move on up, is a fluidity and ease of knowing the multiplication and division facts. So like in our classes, I always have multiplication charts available. And so I know for some students and kids, it's really hard to memorize the facts. And so if they have a lot of practice with the multiplication chart, that's great. But if they have that kind of knowledge embedded in them, it just makes it so much easier as they move up to do harder problems, so they don't get bogged down in the math fact part and lose sight of like the whole thing that we're trying to learn. So this is a list of some fun things to do to practice math facts. It's not just the boring worksheets, which we also do every now and then, but these are some fun things that you can do. So the first one is Ken, and that's the puzzle down at the bottom. And we're going to start doing some of these when we come back to school. But these, depending on what the operation is in the little grid there, you have to multiply, add, subtract, or divide. So that's a great, just like getting ease and fluidity of knowing the math facts. The magic squares is that 9-grid box that's to the right, and that particular one has a mixed number in it, but some of them are just whole numbers, some of them have negative numbers, some of them have fractions, some of them have decimals. So once again, ease of like figuring out sums, what do you need to fill in the empty boxes, using a calculator, great. But just getting some of that math sense and making things a little quicker. Math bingo is fun, playing war with your friend with flashcards or a deck of cards. We each flip over a card, you have to multiply the two numbers. Same thing with dice, if you roll 2 dice, add the 2 numbers and multiply the 2 numbers. Just practice, practice, practice. Shut the Box is a board game that is up there. It's a nice wooden solid board game that's really fun to play with your friends or with your family. Same thing, practicing math facts. Looking at a multiplication chart, writing your own multiplication chart, looking for patterns. What happens when you skip count by 5s? What does it look like on the grid? Area puzzles, there's one there down below. We're going to be working on that when we start area. Practices multiplication facts and addition facts. And logic, problem solving. If you can't figure this out, try a different strategy. Let's see what is going to work to help us figure out the answer. Picture equations are on the right. I love picture equations because it's doing math, but it's fun. Same thing, just practicing problem solving, figuring out what's going to work. What are the patterns? How can we do this? So math facts. Even if you're just practicing, 10, 15 minutes a day, it's awesome. Every little bit helps. And on the last slide, I put some a website that's really fun that has addition games, multiplication, subtraction, division, 4 different sites. And it's a game that you play and you can have easy level, middle level, or harder level. And it's just good practice. Like I said, 10, 15 minutes a day, just to increase those skills.
All right, so yes, we're getting to the end. I know we've run a little bit over, but we're hoping that one of the takeaways is that you're feeling more encouraged to, as you do these things, also have conversations that focus on like, okay, so why did you give that answer? Because the more that they can see their own thinking, you can see their thinking, the more you can see what direction to kind of take them in. Encourage them to ask questions, because that surfaces some of the math. Like I said, like my son asking, why do they use hexagons in these shopping carts? But then it also has those conversations where you start to bring in that real life vocabulary that'll help them no matter what situation. Like I said, the math may surface. And that ties into the more everyday math they see, the more just every day they see, it helps them to be able to see the connections, like just understanding the simple idea of the price tag is not always the final price. So no matter what state they may live in, like here in California, we don't put tax on food, but other states they do. Understanding that when you pay a loan, there's two parts. There's the principal, which is the initial borrowing, and then the interest. And one class I remember I was teaching, they were just so shocked to find out that when you get a loan for your house, so a mortgage, that you're paying more in interest than you really are on the principal for a long time. So paying down that principal can help cut down that interest. And then, like I said, just understanding the vocabulary within real world problems. A lot of students will get bogged down of, I didn't even know what the problem was asking about because I didn't understand the situation. So the more we expose them to, the bigger they have a heads up. And then also changing our mindset, and I'm guilty of it. Instead of saying I was never good at math, changing something to I struggled learning this math concept, but I look forward to learning it with you, or I don't use this sort of math. I can't remember ever using this, but it might still happen yet. So leaving that door open for them to still learn.
And I think our goals as teachers and then as parents also, because we're both parents, is to just get the kids excited about math, get the kids excited about learning so that when they come into the classroom, their confidence is increased, they're having fun. We can listen to those wonderful conversations they're having when they're working in groups, bouncing ideas off each other, trying different things, increasing critical thinking skills, their logical thought process. So all of these different things that we've showed you are different tools that will help that happen, and they're fun. So hoping you can like find 2, 3, 4, 5 ideas that maybe will help you and just focus on those. And we are always open to questions and ideas and comments, and we love your children.
We tried to address the different learning styles. This could be a presentation all of its own. So if you're still looking at some of the going, oh, my kid would never do well with that, we understand that because there's 4 basic learning styles, kids that do better with visual, kids that do better with auditory, kinesthetic, and there's a video, there's the Go Noodles website that has a lot of the kinesthetic, and then the reading and writing. And then if you talk to other experts, they expand it with 4 more learning styles. So we tried, as we put together this presentation, to present things that would address any of these learning styles. And if you're interested in learning more about what your particular child's learning style is, there are, I got bogged down in the rabbit hole of looking at this and seeing all the different ones. So there's sites that you can assess your child, learn how to best adapt things so that they learn to their style. And then this is the promised resource slide that we said. And our goal when we put this together was to have websites where the resources were free, because we never want you to feel like you have to be spending your money to be able to get these resources. Some of them, such as like Mashup Math, it does have a paid portion of it, but then when you see in the parentheses there at the bottom, it says picture equation puzzles. That particular portion of it is completely free. So some of these, they do have a free component of it, but then they have the paid portion of it. And we vetted these to be able to say that these are good resources in terms of the free component of it, because we are just like you, money is tight and we need to see that it's really good. And if we're paying money, we're trying to get it site-wide for the whole school instead of for individual families. And so now at this point,
wait, one more thing. Did I say math facts are important? Oh yes, I think I did. So bullet point number 6, there is a website you can go to that has the math facts games. Super fun. It's fun playing it. So 10 to 15 minutes a day, people. It'll really help things a lot.
So any questions or concerns that you guys have for us?
Thank you so much. There's so much great material here. Will you be putting this PowerPoint out to us so we have all the links, or should we be taking pictures?
Well, we can work on getting it shared out through like Google Class, or not, sorry, I'm already in classroom mode too.
Parents,
Like through Parent Square, that sort of thing. If you don't see it come through, if you guys like email one of us, we could also get it made sure that it gets to you. We hyperlinked it all, but then we're like, right, we have to be able to share it with them so the hyperlink works.
yes, thank you. You put a lot of work into it. I really appreciate it.
Thank you. Other questions or concerns, or would like to hear a little more about something? Because we feel like we kind of turboed through that whole thing.
I was gonna
Do you have any?
say, oh, sorry. I was gonna say we are hoping to hopefully push out like a YouTube channel for Endeavor, for like resources for parents to go to find like math videos to help them teach math at home. As well as Mrs. Vaccaro and I are trying to start a binder for like an interactive math notebook, so that you guys, parents can start really having their student like take notes, and it's like a tool that they, the students can go back and review like things that they don't remember. So sort of look out for those things in the near future. It's kind of like some things that we're working on.
I love the math and nature. We should do a field trip in nature, and you guys can tell us all about math and nature.
That would be
Great
super
idea.
awesome.
That is a good idea.
Thank you so much, math teachers. I think this was great. And again, this will be recorded for folks who couldn't show up and in person today. And we'll let you get back to your day. I'll be stopping the recording.
Thank you for coming, you guys.
Everyone.
Thank you, Mrs. Chugg
Thank
and